Earth is not normal. Most people think it is. They look at the sky, they look at the ground beneath their feet, and they assume this is just what planets look like. A rock with some water, a ball of dirt with some trees, nothing special. That assumption is wrong. Your existence, every breath you just took, every city you've ever seen, every forest, every ocean, every human being who has ever lived depends on a chain of events so unlikely that scientists still struggle to explain how they all happened. Earth didn't get lucky once. Earth got lucky over and over and over again. The strange part isn't that Earth got lucky. The strange part is how many times it got lucky. And the even stranger part, most of these lucky breaks happened before life even existed. As if something was preparing the stage. Here's the question we're going to explore. How many cosmic accidents had to go right before humans could exist? Let's start with the obvious one. Earth sits in the habitable zone. Not too close to the sun, not too far, just right. That sounds ordinary. It isn't. Venus is too close. Mars is too far. Earth is exactly where it needs to be. But that's just the beginning, because being in the habitable zone doesn't guarantee anything. Venus is technically in the habitable zone's inner edge, so is Mars on the outer edge. Both are dead. Venus has a runaway greenhouse effect that turned it into a 460-degree oven. Mars lost its atmosphere and froze. Earth didn't just end up in the right spot. Earth stayed in the right spot. Its orbit is remarkably stable, nearly circular, with an eccentricity of only about 0.0167. That stability has lasted for billions of years. A slightly more elliptical orbit would have meant extreme temperature swings, summers that boil, winters that freeze. Life as we know it couldn't adapt, but stability requires a reason, and the reason is something most people never think about: the moon. Most people look at the moon and see a pretty light in the night sky. They don't realize that without it, Earth would be a very different planet. Earth's axis is tilted at 23.5 degrees. That tilt gives us seasons. But without the moon, that tilt would wobble dramatically. Over tens of thousands of years, Earth's axis could swing from 0 to 85 degrees. Seasons would become chaotic. Ice ages would come and go unpredictably. Complex life would struggle to evolve. The moon stabilizes that tilt. Here's the strange part. The moon shouldn't exist. Not really. Most rocky planets don't have moons this large relative to their size. Mars has 2 tiny moons that are essentially captured asteroids. Venus has none. Earth has a moon that's 1¼ its diameter. Unusually large for a rocky planet. How did it get there? The leading explanation is the giant impact hypothesis. About 4.5 billion years ago, a Mars-sized body called Theia collided with the early Earth. The impact was so violent that it vaporized rock and flung debris into orbit. That debris coalesced into the moon. Think about that. A Mars-sized planet slammed into Earth. Most such impacts would have destroyed both bodies. But this one happened at just the right angle, just the right speed, to create a moon that would stabilize our planet for billions of years. A cosmic accident, one of many. But the moon isn't the only protector. Jupiter. Jupiter is the largest planet in our solar system, with a mass 2.5 times greater than all the other planets combined. It sits out there like a cosmic bouncer. Its immense gravity deflects or captures countless asteroids and comets that would otherwise head toward Earth. In 1994, comet Shoemaker-Levy 9 was torn apart by Jupiter's gravity and slammed into the gas giant. The largest fragment released energy equivalent to 6 trillion tons of TNT, 750 times the entire global nuclear arsenal. If that comet had hit Earth instead, our planet would have suffered a catastrophe beyond imagination. Jupiter has likely been doing this for billions of years, acting as a shield, deflecting threats, making Earth safer. But here's the thing. Some scientists argue Jupiter's gravity also redirects objects toward Earth. The asteroid that killed the dinosaurs 66 million years ago may have been pulled into the inner solar system by Jupiter's gravity. Even our protectors can be dangerous. That's the pattern with Earth. Every advantage comes with risk. Every system that protects us could also destroy us. And yet, somehow, we keep surviving. Let's go deeper. Under your feet, thousands of kilometers below the surface, something extraordinary is happening. Earth's core is molten iron, churning and convecting. That motion generates a magnetic field that stretches far into space. This invisible shield deflects solar wind and cosmic radiation. Without it, the sun would strip away our atmosphere, exactly what happened to Mars. Earth's magnetic field is at least 4.2 billion years old. It has protected this planet almost since its formation. That's remarkable. Many rocky planets don't have magnetic fields at all. Those that do often lose them as their cores cool and solidify. Earth's core is still hot, still churning, still protecting us. But what keeps the core hot? Radioactive elements, uranium and thorium deep inside Earth decay over billions of years, releasing heat. That heat drives convection in the outer core, which generates the magnetic field. That heat also drives plate tectonics. Plate tectonics might be Earth's most underappreciated advantage. Most rocky planets don't have plate tectonics. Earth is unique in our solar system, the only planet with both plate tectonics and liquid water on its surface. Why does that matter? Plate tectonics regulates Earth's carbon cycle. Volcanoes release carbon dioxide into the atmosphere. Rain pulls it back down. Subduction zones carry carbon into the mantle. This cycle has kept Earth's temperature stable for billions of years. Without plate tectonics, carbon dioxide would build up in the atmosphere, runaway greenhouse, Venus, or it would get locked in rocks, permanent ice age, Mars. Earth has neither problem. But plate tectonics is fragile. It depends on just the right amount of internal heat. Too much heat, and the crust is too thin to form plates. Too little heat, and the plates freeze solid. Earth sits in the Goldilocks zone of internal heat, not too hot, not too cold, just right. And that heat comes from radioactive decay, which depends on the right mix of elements, which came from supernovae that exploded billions of years before Earth even formed. Every layer of luck builds on another. Now let's talk about water. Water covers 71% of Earth's surface. That's a lot. But where did all that water come from? Scientists still debate this. Some think comets delivered it. Others think it was trapped in the rocks that formed Earth. Either way, Earth ended up with an unreasonable amount of water. But here's the strange part. Ice floats. That sounds trivial. It isn't. If ice sank, lakes and oceans would freeze from the bottom up. Once ice formed at the bottom, it would never melt. Eventually, entire oceans would freeze solid. Life in the water would die. Ice floats because water is densest at 4 degrees Celsius. That's unusual. Most liquids get denser as they cool until they freeze. Water doesn't. This anomaly, this one chemical quirk, may have been essential for life, and yet Earth is frozen over anyway. At least twice in Earth's history, the entire planet turned into a snowball. About 720 to 635 million years ago, ice covered the surface from pole to pole. The first event lasted 56 million years. The second lasted 4 million years. Temperatures dropped to minus 50 degrees Celsius. Life survived. How? Under the ice. In the deep ocean near hydrothermal vents, life clung on. Volcanic activity continued. Heat from Earth's interior kept some water liquid. When the volcanoes finally released enough carbon dioxide to create a runaway greenhouse effect, the ice melted. This happened not once, but twice. Earth recovered both times. Most planets wouldn't recover. Once a planet freezes over, the ice reflects sunlight, making it even colder. A feedback loop, a death spiral. Earth escaped that spiral twice. Because volcanoes kept pumping greenhouse gases into the atmosphere. Because plate tectonics kept working. Because the internal heat never stopped. More luck. More coincidences. Life appeared on Earth astonishingly early. The earliest known fossils are about 3.5 billion years old. Some evidence suggests life may have emerged as early as 4.1 billion years ago, just a few hundred million years after Earth formed. Earth formed 4.56 billion years ago. The Hadean Eon, the first 600 million years, was a hellish period of volcanic activity and constant asteroid impacts. Life appeared as soon as conditions allowed, maybe even before conditions were stable. But here's the thing. Simple life is one thing. Complex life is another. For billions of years, Earth had only single-celled organisms, bacteria, archaea. Then, about 1.7 billion years ago, something changed. Eukaryotes appeared, cells with nuclei. This transition took an astonishingly long time. It may have been a low-probability event, something that happens rarely in the universe. Then came multicellular life, then animals, then plants, then intelligence. Each step required conditions that had to remain stable for billions of years. The rare Earth hypothesis, proposed by Peter Ward and Donald Brownlee, argues that complex life may be incredibly rare in the universe. Simple life might be common, bacteria might exist on many planets, but complex intelligent life, that requires an extraordinary combination of conditions. The right distance from the sun, the right orbit, the right moon, the right magnetic field, the right plate tectonics, the right internal heat, the right amount of water, the right chemical properties, the right galactic location, far enough from the center to avoid deadly radiation, close enough to have heavy elements. And all of these conditions must persist for billions of years. Earth has survived 5 major mass extinctions. Each time, life recovered. Each time, the planet rebounded. But many planets wouldn't recover. Many planets would become dead worlds after just one extinction event. Earth kept going. So, here's the question we've been circling since the beginning. How many cosmic accidents had to go right before humans could exist? We don't know the answer. Scientists are still calculating. But we know this much. It's more than 1. It's more than 10. It's dozens of separate conditions, each one improbable, all of them aligning at the same time, in the same place, for the same planet. And the most remarkable part? Earth didn't get lucky once. Earth got lucky continuously, for billions of years. The real miracle isn't location. It isn't water. It isn't gravity. It isn't the moon. The real miracle is that all of these systems remained compatible long enough for intelligence to emerge. That's the part nobody talks about. Any one system could have failed. The magnetic field could have collapsed. The plate tectonics could have stopped. The orbit could have destabilized. The moon could have drifted away. Any of these things could have ended the experiment, but none of them did. Not once, for billions of years. So maybe Earth isn't unique. Maybe somewhere out there, orbiting some distant star, another planet has all the same advantages. Another moon stabilizes another world. Another Jupiter protects another solar system. Another magnetic field shields another atmosphere. But maybe not. Maybe Earth is one of the rarest environments ever discovered. Maybe humanity exists because a planet won a lottery it didn't even know it was playing. And maybe, just maybe, that makes every single person who has ever lived far more extraordinary than they realize. Because we didn't just appear on any planet, we appeared on Earth. And Earth might be the luckiest planet in the universe.